Hi, welcome back to my channel. My name is Gina. In this video, we are going to talk about how to find an area between curves using the horizontal rectangle representation. I have a video on how to find an area between curves using the vertical rectangle representation. If you want to review the video, I'll put the link up there. Before we talk about the horizontal rectangle representation, let's do a quick recap. So the idea is, we want to find the area between curves over an interval a to b. And to do that, we split this area into smaller rectangles. For example, let's consider this rectangle. And the area of this rectangle is the height times the base. The height is the y value at the top minus the y value at the bottom. And the width of this rectangle is delta x. And if we have infinitely many subintervals, then we can write this as f of x minus g of x, and the delta x becomes dx. And we can use an alternative approach, which is using the horizontal rectangles. For example, here we have a function g of x on the left and a function f of x on the right. But instead of looking vertical rectangles, now we are going to consider horizontal rectangles. And we also subdivide the interval, but now the interval is on the y-axis, and let's call the width of each rectangle delta y. And let's call the x value at the right xr, and the x value at the left xl. So the area of one rectangle is the height xr minus xl, and the width is delta y, which equals to the inverse function of f of x minus the inverse function of g of x times delta y. So the total area will be the integral of this equation here, which is the integral of the inverse function of f minus the inverse function of g times dy. And the bound here is from c to d, the interval for the y values. Now let's look at this same example as when we talk about the area between curves using the vertical rectangles. But now we are going to use the horizontal rectangle representation. A quick recap, the area that we want to find is bounded between f of x, h of x, g of x, and k of x. And in that video, we found this area by splitting the area into two smaller areas. And we sum up the area on the left and the area on the right. But here, if we use the horizontal rectangle representation, we only need to compute one integral. Let's call the x value at the right xr, and the x value at the left xl. So we want to find the area bounded between h of x and k of x over the interval 0 to 1 on the y-axis. And to use the formula that I just described above, we need to find the inverse function of h of x and k of x. H of x is y equals to x. So its inverse function, x equals to y. And for k of x, y equals to ln of x. So its inverse function, x equals to e to the power of y. Now let's set up the integral. The total area equals to integral of xr minus xl dy evaluated from 0 to 1. XR is the inverse function of k of x, which is e to the power of y, minus XL, which is the inverse function of h of x, which is y, evaluated from 0 to 1, which equals to e to the power of y minus y squared over 2, evaluated from 0 to 1, which equals to e to the power of 1 minus 1 over 2 minus e to the power of 0 minus 0, which equals to e minus half minus 1, which equals to e minus 3 over 2, which is the same as what we have found in the other video. And that is the end of the video. If you are interested in learning more in Calculus 2, I'll put the link to my online course down below. If you like my videos, please like and subscribe, and I'll see you in the next video.